Uh, Hello everyone, welcome to iExamB. Please subscribe to the channel and press the bell icon. This is Aditi, Economics faculty at iExamB, and in today's session, we'll be talking about some of the concepts related to econometrics, which is also relevant for the upcoming SEBI Grade A Research examination. So today we'll be focusing on mainly the SEBI Grade A Research examination and the econometrics and statistics portion of that. So, before moving forward, let's first look at the examination pattern of the phase one exam. So, the phase one is divided into two papers, paper one and paper two. Paper one comprises of four sections, which is the general awareness, English language, quantitative aptitude, and reasoning. So you have around 60 minutes you get to complete this session, right? And it's of around it's the total is of 100 marks and the cutoff is 30%, right? So this is the broadly this is what is asked in the paper one. And in the paper two research stream, you have multiple choice questions on subjects related to economics, econometrics, statistics, finance, and commerce. Right. So, uh, in today's session, we'll be focusing on this area, the econometrics portion. About 50 questions are there from paper two, and the time allotted is 100, 40 minutes, and maximum marks is 100. So, and the cutoff is minimum cutoff that you need to clear is 40% for this paper. Right. So, this is the pattern for the phase one examination. Now, the research stream syllabus, let's look at the details of the syllabus of the research stream paper. So in the economics section, you have there is demand and supply, right? There is market structure, national income, determination of output and employment. So from the microeconomic section, there are only two topics: demand and supply and market structure. And the rest topics from the core economics is from the macroeconomic section, which is national income, determination of output and employment, investment function, multiplier and accelerator, demand supply, ISLM, inflation and Phillips curve, and business cycle. So all these topics from the economic section. Then from the public economic section, you have public goods, taxation, budget multiplier, public debt, public budget. All these topics are covered in the public economic section. So, if you ask me the analysis of the previous year question paper, 2021, that came last year, about uh, 29 questions were from the first section, the economics section. Okay, out of 50 questions, this is. So, a good amount of questions were from this section, the first section, right? This is 29 questions out of 50. And public economics had around 3 to 4 questions. And in the statistics and econometric section, you have various basic topics only, like measures of central tendency, dispersions, correlations, sampling method, sampling distribution, right? So, and hypothesis testing and regression analysis. So basically these tools of statistics, first you learn in statistics measures of central tendency, dispersion, correlation, all these things, and then these are then applied in the econometrics portion while doing the regression analysis. Okay, so uh, and in the international economic section, we have balance of payments, forex exchange markets, role of international financial institutions, BIS, IOSCO, IMF, and World Bank. So only the basic things, like if I tell you a brief analysis of the previous year paper, you only need to, even if you can prepare only the basic concepts from the syllabus, like if you can prepare what a public good is, right, and what are the different measures of central tendency and how the three measures are different from each other, and which are the areas where you need to use one and in place of the other, right? So even a basic understanding of all these concepts can give you a very good marks in the examination. And the this section had about 10 questions in the previous year paper. So yeah, after the first section, I would say this had the highest number of questions. So yes, do not neglect this section. This is a very important and very scoring section as well. Then international economics had these subtopics, right? From the financial markets, we had there's asymmetric information, market model, market efficiency, primary market, secondary market, and so on. Various other topics, speculation and arbitrage. So this is the broad syllabus of the research paper, right? And this is the syllabus is common for both the phase 1 and the phase 2 examination. So if you prepare well for the phase 1 examination, it's not like that you need to go beyond the syllabus and do something else for the phase 2 examination. Both the preparation for the phase 1 and phase 2 can be done simultaneously, just that the level of questions will be higher in the phase 2 examination. Okay. Now, moving forward, in today's session, what we'll be doing is we'll be discussing some questions related to the statistics and econometrics portion, and thereby, like, we'll be revising our concepts by discussing those questions, which is and the level of questions is like the previous year research examination, SEBI Grade A Research examination. So, this will give you a very good practice of the examination also, which is next month, right? So and the first question, let's look at this. A process by which we estimate the value of dependent variable on the basis of one or more independent variables is called what? So let's look at first, what would you understand by dependent and independent variables? So obviously, as the name suggests, dependent is something which is dependent on something else, some other variable, right? And independent is independent of everything. It doesn't depend on any of the variable. So right. So if in the simple regression model with two variables, if you write the equation, it is if y is equal to a plus bx. If this is the general form, if this is the way I write this equation, then what does this mean? That which is the independent variable and the dependent variable? Obviously, for different values of x, you can decipher from this equation that from different value for different values of x, you will get different values of y, right? So obviously, this means that the x variable is independent, right? And uh, for and the y variable is then the dependent variable, right? So this is the general form of regression line where y is dependent on x, right? So let's look at the now come back to the question. So it is asking that the process by which we estimate this value of the dependent variable on the basis of one or more independent variables, what is this process known as? So uh, it's either correlation, regression, residual, slope, or intercept. Uh, would you like to answer in the comments in the live chat? Okay, Shivan, I have already answered this question that about the level of questions from econometrics. The kind of questions that we'll be practicing here right now is the level of questions that will be there in the research paper. Okay, and JDM, we will be coming up with a lot more videos, right, on the research stream paper questions. This is being one of them. Okay, good morning, everyone. So, uh, this is uh, the process by which we estimate a particular variable, the value of the dependent variable. This process is known as the regression. Okay, this process is called the regression. Okay, whereas correlation is a statistical measure, right? It's a statistical estimate by that we get of in order to when we estimate the value of the dependent variable on this independent variable. Okay, and residuals and slope and intercept are these terms. When I write y is equal to a plus bx, right? Uh, the slope is given by this b, and a is the intercept term, right? And residual is, we'll be just talking about this in later slides when I talk about the ordinary least square method that is being used in the regression analysis. Okay. Next question. The method of least squares, yes, dictates that we choose a regression line where the sum of the square of deviations of the points from the line is, the options are maximum, minimum, zero, positive, negative, right? What is, uh, what would you get when you do the ordinary least square, when you apply the ordinary least square method in order to choose when you regress one variable on other, then the sum of the square of deviations of the points from the line. So what it is trying to say is that, let's say this is the regression line, right, that I have. So let's say if this is the x axis, x, and this is y variable. So I have several points here, right? Uh, for different values of x, for and there are different values of y. Now, what the in order to fit this regression line, the ordinary least square method suggests that the error terms, that is the difference between this point and the mean, this should be the minimum, right? And why this and the sum of the square of deviations from the points from the line should be minimum, right? Why do we take the square? Because if you don't do the square, the positive and the negative deviations will cancel out, and ultimately the sum will be close to zero. That's why we need to take the sum of the square of deviations, right? Then only you'll get the true picture as to what the true deviations are from the regression line, right? So what, obviously, as you would want that there's least number of deviations, right, from the regression line. So yes, question, the deviations should be minimum, right? That's the correct answer. Now, if you are interested in the previous year question paper, you can visit our website. On the home page, go to free mock test. Under free mock test, SEBI mock test, and under the SEBI mock test, grade A phase 1 previous year question papers, you will find the research paper that came last year. Okay, this is available on our website. You can access it from there. Okay, uh, and it's available for free, right? You can attempt the test there to have an idea of the kind of questions that appeared in the previous examination, right? Now, let's look at another question. If R is equal to 1, the regression lines will be dashed to each other. What does it mean? Parallel to each other, coincide, or it will be apart from each other, perpendicular to each other, or none of these? Please answer in the chat box. Yeah. So, if the coefficient of correlation, that is the value of R, is equal to 1, this means that there is perfect positive correlation, right? And if there's perfect positive correlation, then the regression line will be uh, positively sloped, and the two lines will coincide on each other because there is perfect positive correlation between the x variable and the y variable. So perfect positive correlation, right? So the two lines will coincide, right? Uh, Next question is, in the classical linear regression model, if we add 690 in x and y observation and re-estimate the regression model, then what happens to the slope coefficient? So what it is saying that uh, regression model in the classical, it's or talking about the classical linear regression model, right? If we add 690 and in x and y observations, so let's say if my x is, let's say, 25, or y x, uh, let's say the regression line is y is equal to a plus bx, right? So if I add 90 in both these observations, right, in the x and y observations, then what happens to the value of r, right? uh, then what happens to the slope coefficient, which is this, right? So will it increase by 90, decrease by 90, or remain same, or none of these, right? So we know that the slope coefficient, it is or decrease more than 90. So we know that the slope coefficient is independent of change of origin, right? So there shouldn't be any change in the if we add 90, or even if we subtract 90 or do anything. So that there shouldn't be any change in the x and y in the slope coefficient, right? So it will remain same. It will not change. Okay. Now, moving to the next question. The value we would predict for the dependent variable when the independent variables are all equal to zero is called, the options are slope, sum of residual, intercept, or it's difficult to tell, or none of these. So here, the value that you would predict when the dependent variable, for the dependent variable, so dependent, let's say if I'm writing this equation as y equals to a plus bx, right? If this is the dependent variable and it's saying that the independent variables are all equal to zero, this x is all equal to zero. So obviously if this is equal to zero, what am I left with? A, right? Which is the intercept of the equation. So the correct answer is that the value that you would predict for the dependent variable when the independent variables are all equal to zero is the slope of the equation. Okay, right, right, Ninand. Next question. The predicted rate of response of the dependent variable to changes in the independent variable is called, the options are slope, sum of residual, intercept, error, or the regression equation. So here, the predicted rate of response of the dependent variable to changes in independent variable. So what is it trying to say? That if this is the regression equation, y is equal to a plus bx, okay, the rate of response of dependent variable, for what it means, that by how much this independent variable will change for a change in the independent variable this. So obviously we know that the slope is the measure which measures this rate of change, which is given by b. Like for, if this is the regression line, right, if I move from here to here, right? So if x, this, let's say this is the value of this x has a value of 2, and let's say this is y, which is 3, right? If I move from here to here, let's say this is 4, and let's say this is 5. So obviously this change will be given by the slope of the line, right? By how much, if you change the x variable, then by how much the dependent variable, though there will be a change in the y value, right? So the correct answer is the slope, which is the predicted rate of response of the dependent variable to changes in the independent variable. Okay. Next question. If the value of any regression coefficient is zero, then the two variables are, options are qualitative, correlation, dependent, independent, none of these. Uh, you can reply in the chat box if you want. uh, the value of any correlation coefficient, the value of any regression coefficient is zero, right? This is given to us. Then the two variables, what happens to the two variables? Are they qualitative in nature? Are they correlated? Are they dependent on each other? Are they independent? So if the regression coefficient is zero, right, this means that the nothing is explained, right, between the two variables. You cannot say that there is any correlation between the two variables, and so the variables would be independent of each other, right? So the correct answer is they be independent. Next question. If y, yes, very good, Amnish. It's D, independent. If y is equal to 2 minus 0.2x, then the value of y-intercept is equal to, the options are minus 0.2, 2, 0.2x, or 0.2, or all of the above, right? So what is the y-intercept? If I write the equation as y is equal to a plus bx, then what is the y-intercept here? D. All of you agree that the correct answer should be 0.2 D. Okay. Why not minus 0.2? See, I am taking a standard form of the regression line, right? But the B could be positive or negative, right? So if my y is equal to 2 minus 0.2x, that means this can be written as 2 plus minus 0.2x, right? So the value of b is minus 0.2, and it's only asking for the y-intercept. That's why 0.2x is not right, 2 is not right, right? So the correct answer is minus 0.2. Okay, moving to the next question. If one regression coefficient is greater than 1, then the other will be. The options are more than 1, equal to 1, less than 1, equal to minus 1, or equal to plus 1. So the regression coefficient, right? If you are regressing y on x, that is, if you write y is equal to a plus bx, where y is the dependent variable and x is the independent variable, that means you are regressing y on x, right? But if you write x is equal to a plus by, where x is the dependent variable and y is the independent variable, that means you are regressing x on y, right? This is the difference. Now, if one of the regression coefficient, it's saying if one of the regression coefficient is greater than 1, then what's the value of the other, right? So if one of them is greater than 1, that is, let's say if one of the regression coefficients, let's say if bxy is greater than 1, then what's the value of the other, which is byx, right? So we know that in the simple regression model, the product of the two regression coefficients bxy and byx, right, has to be less than 1, right? This is known to us that it is less than 1, it lies between 0 and 1, right? So if one of them is greater than 1, then obviously the other has to be less than 1. Yes, good. So the correct answer is C, less than 1. Next question. The regression equation always passes through. Options are xy, ab, x bar y bar, x bar y, or x y bar. What what is the point through which the regression equation will always pass through? So if, let's say, if this is the uh, if this is the regression line, let's say if uh, now if my regression equation is y is equal to a plus bx, let's say, right? uh, Now, how do I know that which is the point through which it will pass always? So let's now obviously you can, through the process of least square estimates, right? When you minimize the sum of the squares of the error terms, and when you put the first order differentiation equal to zero, when you equate this to equal to zero, you will get that the regression line will always pass through the mean value, mean of both x bar and y bar. You can also derive it, using the normal equations, which is the normal equations for the for this is summation yi is equal to a plus b summation xi, and the other normal equation is summation xi yi is equal to a, right, a summation xi plus b summation xi square. These are the two normal equations. Now, when you divide the first normal equation by n, divide it by n, what do you get? Summation yi is equal to a plus b summation xi. Divide this by n, the whole thing you have y bar is equal to, right, n a plus b x bar, right? This is what you have, right? So that means this satisfies this particular uh, line, and so this regression equation will pass through x bar y bar, right? It has to pass through the mean because it's the regression equation, we are trying to fit the regression line between the 2 points. So obviously the average, it has to pass through the average of the two variables, right? uh, the regression. So xy ab x bar y bar. The correct answer is x bar y bar. The next question: the correlation coefficient is dash of the two regression coefficients. The options are geometric mean, arithmetic mean, harmonic mean, median, or none of these. Right. So what happens? What is the correlation coefficient? Is it the geometric mean or the arithmetic mean, harmonic mean, or the median of two regression coefficients? So the regression coefficients, if I'm regressing x on y, I have bxy. If I'm regressing y on x, I have b by x, right? These are the two regression coefficients. Now, the correlation coefficient R, right, which is the covariance between the two variables x and y upon the standard deviation of x times standard deviation of y. This, what, how are these two related, right? This is what the question is asking. This two, what's the relation between the two? Would you like to answer in the chat? What is there a geometric is it the geometric mean of the two, or the arithmetic mean, or the harmonic mean, or the median of this value? Yeah. So R basically, in order to the coefficient of correlation R is the product of bxy, byx, and the square root of this. So R squared is the product of bxy times byx. Okay, this is what we know, that the product of the two regression coefficient is r square in the simple linear regression model, right? And when you square root this, you have the coefficient of correlation, which is r. Now this is also similar to that is what we do in geometric mean. Geometric mean is the square root of, right, square root of the variables, two variables. So you can say that the correlation coefficient here is the geometric mean of these two regression coefficients bxy and byx. Right. So this is the geometric mean of the two correlation coefficients. Uh, Next question is if both the variables x and y increase or decrease simultaneously, either they are increasing or they are decreasing, then the coefficient of correlation will be, the options are positive, negative, 0, 1, or none of these. Right. So if both of them are increasing, what does it mean? That there is this, it's depicting a positive relationship, right? Again, if both of them are, what is a positive relationship, right? For if there is some change in this variable, then there's also a proportionate change in the other variable, right, in the same direction. If they are decreasing, right, then if my x variable changes from this point to this point, then my y variable is also falling, right? So obviously the relationship between the two will be positive. Yes, right, Amish. So the relationship between the two variables is positive. Next question is if bxy is given to be zero point 0.2 and the value of rxy, the correlation coefficient, is zero point 0.5, then what is the value of byx? So in the examination on only direct application of the numeric formula are asked. Such type of questions are asked where you have to directly apply the formulas. So this is a very direct application of formula. The options are 0.2, 0.25, 0.5, 1.25, and minus 1.25. Right. So if we know that one of the regression coefficient is not known to us and the other is known to us, and the correlation coefficient between the two variables is known to us. So we just previously discussed in the previous slide that the correlation coefficient is the geometric mean between these two variables, right? So how will you get the value of rxy? How will you get the value of byx when rxy is given and b of xy is given? So we know that this r is the geometric mean of bxy and byx, right? This value is given, this is given to us. You need to find out this. So when you just put the values of zero point 0.2 and zero point 0.5 here, right? Times byx, right? When you do this, you'll get the value of byx, which is the value of byx is 1.25 in this case, right? Next question. The estimated regression model is given by y is equal to 10 plus 0.6x, right? And x is equal to minus 4 plus 1.5y. Then the coefficient of determination is given by what? So the coefficient of determination is r squared, right? Basically, explains it is the ratio of ESS upon TSS. So ESS is the explained sum of squares and TSS is the total sum of squares. So it is telling you the proportion that is being explained by the independent variable for the dependent variable. It's the ratio of explained sum of squares to the total sum of squares. And in the simple regression model, this coefficient, this r, capital R square, is equal to small r square. It's the same thing, right? So we need to find out this coefficient of determination. So in short, if we need to find out capital R square, that is, we need to find, it's asking you to find the coefficient of correlation, right? And the coefficient of correlation, it's asking you to find out the R squared, right? So coefficient of correlation is the geometric mean of byx times bxy, and we have the value of both. This is the regression equation of y on x, and this is the regression equation of x on y, right? So that means byx here is 0. 0.6 and bxy here is 1.5, right? Then you take the geometric mean of these two, 0. 0.6 and 1.5. And after taking the geometric mean, you'll get the value of r, right? Square it, you'll get the value of r squared, which is also the coefficient of determination. So the options here are 0.36, 0.6, 1.8, 1, and 0.9, right? The correct option, when you put the values there and solve it, the correct answer that you get is 0.9. That is the value. Next question. For two correlated variables x and y, if the coefficient of correlation between x and y is 0.9, the coefficient of correlation between the two variables x and y is 0.9, and the variance of x and y is 16 and 25 respectively, then the covariance between x and y is what? So covariance basically tells you how the two variables vary together, and it is uh, and the formula, the relationship which describes the relationship between the coefficient of correlation and the covariance is that the coefficient of correlation is given by the is equal to the covariance between x and y upon the standard deviation of x times the standard deviation of y. Right? This is the coefficient of correlation between x and y. So we have the value of variance of x, we have the value of variance of y. When you square root these two, you get the standard deviation of x and the standard deviation of y. These two, right? And you the value of coefficient of correlation, which is the r, is also given. So you need to find out the covariance between x and y. It's easy to do. Now we can put the values here. So coefficient of correlation is what? 0.9 is equal to covariance between x and y, right, upon the standard deviation of x, right, which is 4, and the standard deviation of 5 y, which is 5. 4 times 5. Now when you solve this, you'll get the covariance between x and y. The options are 18, 19, 20, 360, and 17, right? The correct answer is 18 in this case. So these are the several kinds of questions, you know, on the lines of the previous year examination that can come. And by practicing these questions, you can revise your concepts of econometrics and regression analysis. And for any kind of guidance, you can visit our website. And right now, we are offering flat 40% on all the courses for SEBI, General Legal IT Research Rajbhasha. You just need to use the code SEBI40 to enroll into the course. You will get video lessons, study notes, practice tests, and live sessions, as well as interview guidance with experts. So this is what is what you will get when you enroll into the course. So and if you have any kind of query, you can email us on this email ID, hello@iexambi.com, or you can contact on this number 920 or you can also visit our website for any kind of query related to the examination. All the best. Thank you so much.